What really about networking? So I'm gonna try to explain to you like Hero 5. So I hope you enjoy it. And well, and basically in the very abstraction, we're talking about a way of communication. So we want to exchange information from point A to point B, and we want to be able to have a server and a client in order to exchange information and have it being unilateral, just the client send information to the server, or the other way around as well, the server send information to the client. And we had a lot of user cases for this, like usually you might get into that when you're trying to access a web browser and watch a movie or listen to a music or watch a video, for example, or even access your email. And in this case, you will be the red circle trying to access the server through your web browser, and the green one is going to be the server, just waiting for your connection and then to send back you some response with that. And we have also the gaming way of doing networking, which is like, let's say you invite your friends to play multiplayer games, and you will have a lot of different connections, like the clients are going to be the circles with the computers, and they're going to be accessing sometimes the same server, sometimes not the same server. It depends on how the game is implemented. Let's say they're trying to play some open world, and you're located here in Denver, and I'm located in Brazil, where I'm from. And we're probably going to be connecting to different servers, but we are going to be exchanging the same information. So in order for you to know where I'm at, in order for you to know that I'm here speaking to you, you need to know this information. So I'm going to send this information to the server, and the server is going to broadcast this information to all the players that are currently near to me. And also we have the case for development, where we're creating a backend application using Phoenix, for example, something like that. And our application accesses a database, or trying to access a GraphQL or any external interface that we need to connect to as a source of truth. And it's all about communication. So it's all networking protocols running below that. And why is it really useful for me? So why am I need to use networking, and why am I need to understand how networks works? Mostly because, let's say that you're trying to implement something that needs that, like a streaming platform, or even a game, or something that works with a different protocol that you don't have a library yet for that. So you might need to understand how that works in order to create a library for that. And also, one of the things that I enjoy the most is actually because when you understand, when you keep studying new things and understand the abstraction of that, you unlock a new achievement on your head, which is the problem solving. You just improve the problem solving achievement. So you can, you feel comfortable to solve new issues, and whenever you feel over some pressure like that, you can easily go back and see, oh, I have studied this right now, so I know how to fix this. I know how to solve this issue. And a couple of scenarios that I found. I mean, I don't know, who here works with GraphQL already? I mean, yeah, pretty much everyone. I don't know if you guys, you're using GraphQL on Elixir to consume, to ingest data. I mean, as a client for GraphQL. So yeah. If you go back, I don't know, a couple of years ago, you wouldn't have that. You would need to, I still don't know if we have a reliable library for that, but if you go back in time a couple of years ago, you wouldn't have a library for that. You would need to understand how GraphQL works in order to implement that on top of HTTP client. So you need to create an interface or a library for you in order to use the HTTP client to consume data from the GraphQL endpoint. And this is something quite interesting actually, because you would need to understand how the GraphQL works, and that it works, and that you can consume that data using HTTP clients in order to implement that on your application. And then you could like have a request passing the endpoint that you're going to consume, and the payload that you need to create a query using a string, and then encoding that query and pass it as a body. So this is a very interesting scenario. And the other one is gaming itself that I spoke before. Also because, let's say that you're trying to create a game or any other type of streaming platform, you will need to understand how the networks works, because you will have to make a decision. At some point, you will need to rely on using TCP or UDP or applying a protocol on top of that. And are you going to use a library for that? Are you going to implement your own protocol? Are you going to apply encryption to that? How are you going to work with that in order to keep it safe and keep it fast? I mean, depending on what your needs. So yeah, that's some of the cases that I thought of, and that's really interesting for you to study and know more about it. And my name is Willian Frantz, and I'm a software engineer. I'm currently work for Axteam, which is we do a lot of outsourcing, and we hire people to put as a contractor into companies. And you can find me at this Twitter down here in case you want to chat with me, or just tag me into cat memes. I would like that. And well, so the first thing that I want to talk about actually is transport layer. So we have a couple of videos that is very interesting to understand when we are implementing things on our side. And the first one is the transport layer, because we're talking about everything that goes built in on your machine. So if you're running on top of Linux, if you have a Linux, or if you have a Windows, you already have those things built in because they are on kernel level. So someone had the job to implement the TCP and UDP and set a standard with RFC so that every server, every operating system could have those implementations, those APIs available for you. And well, the TCP itself, it stands for Transmission Control Protocol. It is connection-oriented. And what exactly it means to be connection-oriented? It means that we're trying to establish connection between the client and the server to be like friendly, you know, like, hey, we want to exchange information. I know I want to send you some information, and I want to receive information from you. So before we do that, we need to establish a connection. We need to be able to send a signal, the client to the server, like, hey, I want to connect with you, and the server will be like, hey, yeah, okay, I acknowledge your connection, so you can send information to me. And then they start exchanging information, in fact. And the same needs to happen when you're trying to close a connection. Let's say that you're finishing a connection, and you need to close a connection for any reason. So it's going to happen the same thing. You're going to have a signal being sent from the client, like an acknowledgement of finishing. And the server is going to respond also with OK, and I acknowledge that you're trying to close this connection. And now we can move on. So this is what it means to be connection-oriented. We are just exchanging information if we have a connection pre-established. And until that happens, the server is going to be just listen passively. And one of the things that I marked here is that the TCP protocol is actually considered very reliable, because they have their own way of treating what's happening on the kernel level. So let's say that you're connecting to a server, and some of the packets that you are sending to the server are not being sent or not being delivered to the server, and the client has their own ways of rebroadcasting that and understanding that an error was happening there. So and if you got a timeout, if you got anything that wasn't expected, then the protocol will know how to deal with that, because it's implemented on the kernel level. And we have an API for we are not using the common API, we're using the Gen TCP module here to give a couple of examples, which is the API that accesses the operating system module. And it's on Erlang, but I'm going to call this module from Elixir. So let's say that we want to create a TCP server, right? And this TCP server is going to be listening on the port 3000, and it's going to have a couple of default options for us. Like it's going to be binary, we want to receive all the data as a string, and it's going to be active false, which means that I want to be able to receive the data using the function receive. So every time that I call it gen TCP dot receive, so I'm actually saying, give me the information. And if I didn't set the active false and set active true, what is going to happen here is that actually the information was going to be sent and broadcasted to the process. So I will have to use a callback to receive that information, or you could use the flush if you're using the interactive terminal to flush the information and see the information actually coming from the client. And well, after we set a listen, we will receive a tuple with OK and the socket, which the socket is going to be the server that we just created. And we are now in a passive way of working. We're listening for connections, but we don't have any connections. And once our clients try to reach us and connect with us, we're probably going to accept a connection. So we're going to say, hey, I want to accept this connection. I acknowledge this connection, and I want to receive information from this client. So when this happened, then we probably could receive data from the client. We can use the receive function, and we will be expecting for data from the client, and the data is going to be as a string because we set this as a binary on the first argument, on the second argument actually. And as we can see, we're just using like 3 functions: listen, accept, and receive. And everything that's happening here is happening on the lower level because we didn't need to implement anything other than that. And in order for us to create a TCP client, for example, we would need just to connect with the IP that we have and the port that we established before, and the options, which in this case I didn't set any, but we could set like options for in case I want to access an IPv6 server or something like that. And I would send information to the server. So I would say hello world in this case, which we're still going to see how it's going to be useful in the next chapters. But in this case, I'm just saying hello world, and the server is going to receive, when he calls the receive function, he's going to receive a string like, hey, hello world, something like that. And that's where it becomes interesting, because everything that we do after the transport layer, we're going to do on the application side. We're going to implement that on the application because we need to deal with that. And well, so we talk about the TCP server and the client. Let's take a quick look into the UDP, for example. So on the other side, compared to the TCP, the UDP actually is connectionless, so it doesn't need any connection to be sending information, exchanging information. And it's one characteristic that people say that it actually brings performance to this protocol, because now you don't need to handshake whenever you're trying to connect, establish a connection, or end a connection. You don't really need to care about rebroadcasting packets. Like, you can care about this on application level. So if this is something important for you, you need to have that. You can care about that on the application level and treat that in a way that best fits for you. And so you're just sending packets. So what means is that you're creating a UDP socket and you're saying, hey, I want to be bound to a port like 3000 on the UDP protocol, and I'm listening for connections. Not connections, I'm listening for packets. And the clients were just going to be sending packets to us, and we're going to receive and process those packets. So it's pretty simple compared to the TCP, and it's very well compared to the TCP. And we're going to use the gen UDP on Erlang to call to create a new UDP server and client here. So in TCP we used the listen, because we were saying like, hey, I want to list for connection, I want to connect with people. And here we're just going to say open. I want to bind my server to a port, and I'm going to use the same options like binary and active false, because I want to receive those information and being able to process those information. And after I create a socket to UDP and I say like, hey, bind to this port and start listening, we're gonna just create a new socket on the client, and we're going to say, hey, I want to send information from the socket that I just created, that it's on the client, to this IP and this port, and I want to send this data. I want to say hello road, I want this data to be sent to the server. So the server is going to receive using the same function that we had before, but the difference now is that we're calling actually gen UDP instead of gen TCP, but the data is going to come at the same way. It's going to come as a string, and after that, we can then start handling and processing things in application level and doing whatever we want with that. So things that are interesting about the kernel level, the protocols that we spoke about, the transport layer, is because they are not going to change. They are always that way. They have this standard of being one single socket that is receiving packets, or the TCP that is actually waiting for connections. And we use this a lot on the application layer, which the difference is that the application layer sits on top of the transport layer. So we have the kernel level, and then we have everything that is user space. So if you are creating an application, then it's user space. So your application is going to handle the connections that you are creating, no matter if it's TCP or UDP. So after you establish a connection on TCP, for example, and you start receiving data from that connection, you can then start treating that data in a way that best fits for the protocol that you're using. And we're going to see that all of these protocols actually use TCP, and it's the same structure, and we're just differentiating the way we are treating the data. So the FTP, for example, of course stands for file transferring, but I don't know you guys, but what people call today, like CI/CD, used to call FTP back in the day. Like we used to connect straight to the server and start hot reloading code with FTP. And what actually FTP does is like he sends plain text with comments. Like he's sending comments to the server, and the server is listening to these comments and like, oh, I want to list a directory, I want to delete a file, I want to create a new directory, I want to make login, for example, because we need to log in before we use the server. And of course, it runs on top of TCP. And when I say plain text here, I mean even the username and password, because I'm talking about the standard FTP, not the FTP when you're using TLS, the transport layer security, and not the one that you run on top of SSH when you create a security shell. And well, so these are a couple of data that FTP understands, like the comments. So you have a comment, which is the first argument, and you have a second argument, which is what you're going to pass to that comment. So the first one is user, for example. I'm passing a user with a username, and this username is going to be used to validate the data within the server, and the server will say, okay, this is your name, I understand this is your name, so now give me the password. And then you say pass and the password. So this is all going to be achieved through TCP. So it's going to be something like the client's going to connect to the server, there's going to be the handshake, they're going to be friends, and then the client will say, okay, this is the user that I want to connect, and this is the password that I want to connect, and then the server will say, okay, you're good to go. You can now send me comments, and I will process those comments and give you back some response, some feedback. And in order for us to achieve that in a simple way, like just the essential, we can just copy and paste what we saw before, creating a new socket and saying like, hey, I want to listen on port 3000, and I want to accept connections, and I want to receive data from a client. And with that said, I can just, let's say that I want to process the data that is coming from the client. So I'm not talking about loops here yet. I'm just receiving one connection and receiving one data from the client, and applying a case do here, like, oh, I want to see, in case the person send me a list, I want to list that everything that is on this path on the server side and send back it to the client. Or in case the person send me a comment to change the current directory, so I'm going to change the directory and reply that to the person. Or we could actually add the other comments as well, like in case I want to quit, for example. So if I want to quit, I'm just going to exit and shut down the server connection and say like, oh, okay, we're not connected anymore. So in case you want to connect it again, you need to send me the username and the password again. And this is just a simple example of how we could achieve that by using a couple of lines in Elixir. But of course, if we would like to receive more connections, we'd probably need to handle that with applying a loop here, and probably dispatching some connections to tasks and creating new sockets. And okay, and how would look like the FTP client, for example? The client has a couple of tricks because we need to actually send, we need to be in touch with the client and prompting like, hey, the server is asking for a password, so we probably need to print something for the user, and the user would probably insert the user and the password, and we will send those informations as commands to the server. So we would have like one packet being sent with information being like user and my name, for example, and another information into a different and isolated packets and like pass and I love cats, for example. And with that, I'm just trying to log in into an FTP server, right? And well, so changing a little bit to HTTP. HTTP is just a way of web serving things. Like we are creating a connection, and it's going to be accessible from a browser. You're going to be able to open your browser and type the DNS and access my server. And it runs on top of TCP either. So the difference from what we saw before was just, you're going to realize that it's just the way we're processing the data on the application level. Because on the FTP, we had this type of data being passed, like the user, the argument, the pass the argument, and then we have a proper way of responding that because FTP also has its own response codes. And that's what we're going to see here in the HTTP also, because HTTP has its own ways of dealing with the data. So most of the time we will receive, like we can test this actually in the browser. That's really cool because we're using the HTTP 1.1 and we're not using the TLS option, so it's not going to be encrypted. And we can send information, like let's say that the browser is trying to access your server that you just put on, and what's going to happen is that you're going to receive this first two lines of data, which is the GET, the method, the HTTP method that we're going to send, and the slash, which is going to be the endpoint. Let's say that we're trying to access slash users, or let's say that we're trying to access this from a different method. It would receive like post slash users, and it breaks the line because the HTTP protocol does things by lining. So we will have the first line going to be the method, the URL, the endpoint, and then the protocol that you're using, and then you break the line and you have the rest of the headers, which is going to be, in this case, I use the host and the accept, but you might have a lot of headers, like let's say you're using Chrome, for example. This would be a huge request with a lot of headers. And as you can see here at the end, we have a double break line. We have /r/n/r/n, / actually. And what it means is that we are ending the header protocol and we're actually entering into the body protocol. So in case I was sending a post method to this API, we're going to see the body after this double break. So it was going to be there as a JSON, and we could process that and make a decision from that. And well, the bottom part here actually is the response that we need to get back to the client. So after we receive the data and we process the data, we need to respond back with the same protocol so the browser can really understand what's happening there. Because if you don't set this, then probably the browser wouldn't understand what you're trying to say. In this case, I'm just responding back with a 200 OK and saying like hello world, pretty much what GraphQL does, like 200 every time. And well, so let's say that I'm going to create an HTTP server, right? So I'm going once again run on top of TCP, and I'm going to use pretty much the same code that we used before for the FTP server, because everything that's related to the TCP we're going to do always the same way. I mean, in this case, I'm not using TLS, once again, the transport layer security. So I'm just trying to connect within a TCP server. And I'm creating a TCP server and saying, listen to the port 3000 and accept a socket connection and receive data from that. So After that, I can start receiving data and processing that data. In this case, I'm just receiving a data and ignoring what's being sent on the data, but just sending back a response so the browser can actually load something for me. This actually is one of the cool things because you can test it on the browser. If you create a socket like that and you receive the data and respond like that, the browser will show like hello world for you, like a plain text, so you can see that it's working. And what we could actually do here, like for example, let's say that we want to implement some health check endpoint, for example, we could actually receive the data, and I'm just using string contains to see if there is the get health function, but you could probably split the data that we saw before into break lines and have a double break line after to understand what's the body and what's the header of the request. But in this case, I'm just using the string contains to get the data from this endpoint and validate whether it's health or not. So if it's a health check endpoint, then it will return true, and I will send a success message that we're seeing here. Like I'm responding HTTP 1.1 to 100 OK, the content type and the content length, and just a simple OK just to so people can understand that something went good there. And at the other side, if we don't get the true, if we don't find the get / health, we'll probably get to send to the client a message like, hey, this was not found. So we're just going to need to change the headers that we're responding back to the client. So instead of responding with 300 OK right here, we're going to respond with 404 not found, and I'm just change the content length and the response back. Just said, sorry mate, didn't find what you want. And as I said, what's interesting about this approach when you're trying HTTP servers is that you can actually test it with your browser. You can actually test with curl, for example, and you can even try it by implementing the TCP client. So you could have the same way that we implemented for the FTP, but dealing with the headers that we saw before. So sending this information and expecting a response back. And well, so SMTP, for example, SMTP and the other two one that I listed here, POP3 and IMAP, for example, they are protocols used for mailing. So you want to send a message from a client to another client, and you will have a server in the middle, and that works by just the SMTP being responsible for sending the information, dispatching the information, and the POP3 and the IMAP being responsible for fetching that information because it's user level. So what's happening here is that most of the time you will have your provider, your mailing provider, and when you click to send an email, the SMTP is going to fetch that email that you just created and it's going to send to your provider, and your provider is going to be responsible for fetching that email and send to the other provider. Let's say that the user that you're trying to mail in uses a different provider. So this is going to be dispatched to the other provider, and then at the end, when your friend tries to access his email, he's going to use POP3 or IMAP to fetch that information and read the email. So all of those protocols runs on top of TCP, and they have almost the same approach when we're talking about the raw level, like without authentication, without the transport layer security. They have pretty much the same structure, and they are always going to have a client and a server. So keep that in mind. And one that I listed here that's different is HTTP 3, because I don't know, have you guys heard of HTTP 3? Like, do you know how it works? I've been studying it a couple of months ago because I was trying to understand better how it works, because it feels a little weird to have something that is not TCP these days running on my computer. I mean, I'm used to only having UDP connections for gaming or streaming things, but when I saw that, I found that very interesting because it's a way of serving websites still, but it's running on top of QUIC. QUIC it stands for Quick UDP Connections, and actually creates it actually connects, how can I say that? It creates, you will have the UDP server and you will have the packets being created on the client side, but it's going to be all about application level. So you're going to have, like, for one datagram that you send for time, you're going to have a lot of quick protocols, quick packets being sent. And this change have been interesting because they're saying that now with the HTTP 3, like, there are almost 25% of all websites using HTTP 3 already, I guess. It's a good mark. And they are saying that the changes, the several changes were that actually now you can not worry about the switching of internet protocols. What happens is that UDP doesn't care about the internet connection. So if you're connected to the Wi-Fi resort and then you go to the lobby and you connect to the Wi-Fi public, it doesn't really matter because you don't need to reestablish a new connection. You're just broadcasting the packets to the same IP, and the server is going to understand and is going to respond back. So you don't really have all this layover of losing the connection. And also about the security and the handshaking, because the Quick does handshaking as well, but it does on the level of the protocol instead of the level of the transport. What they does is that when they send a packet to the server, they are already doing the handshake and receiving information from the server. That's pretty interesting, actually. And well, some of the takeaways that I intended to do in this talk is that just to give a quick abstraction about the protocol layers and the difference, because when we think about protocol layers, we can clearly see that transport layer is everything that I don't need to care about. Someone already implemented and I can just use the way they are. We saw that we can implement like a couple of servers, different protocols using the same method, TCP connections. And everything that's application level actually is things that we need to care about on our side. So if we need to implement like a GraphQL, if we need to implement an FTP or something like that, we probably need to fetch those information after we establish the connection and process that. The abstractions is something that I found really interesting because you can use UDP and emulate a lot of TCP does, and that's what we do a lot for gaming. We actually simulating some of the TCP functionalities. So we establish a connection basically with the client and the server, and when we start broadcast data, we need to do all the double check about handshake and trying to guarantee that this connection is encrypted. So this is all on application level, but some of the functionalities that we're doing, we're just replicating from TCP, but on the application level. So I guess this is one of the most interesting things that I found on the difference between TCP and UDP, that you can actually choose what is best fits for your case. So if you really need reliability and things that are already implemented on the kernel level, you can just go with TCP. Or if you can go a little easy on it and you can handle those things on the application, or even if it sounds better for you and you need performance, then you probably would choose over UDP and start creating your protocol. So I hope this stands for you. Well, that's it. Thank you.